Okay, so this is the video for uh, Biology Chapter 2, Part 1, The Chemical Basis of Life. Atoms and atomic bonds. Matter refers to anything that takes up space and has mass. Can exist as a solid, liquid, or gas. Composed of elements. An element is a substance that cannot be broken down into another substance by ordinary chemical means. Only 92 naturally occurring elements. 4 elements make up about 96% of body weight of most living organisms: carbon, hydrogen, oxygen, and nitrogen. Where do elements come from? Normal chemical reactions do not produce elements. The majority of heavier elements, such as iron, are produced when stars explode as a supernova. Supernovas scatter heavier elements into space, which then become parts of planets. The iron in blood was formed by the explosion of stars. That's cool. 2.1 elements in living organisms. So we can see 10% hydrogen, 3% nitrogen, 1.5% calcium, 1.1% phosphorus. There's lesser elements. Lesser elements including sulfur is 0.8 and trace elements is 0.6. Carbon is 18% and oxygen is 65%. Love that. Atomic structure. Atomic theory states that elements consist of atoms. Atomic symbol. Name of the atom or element. H for hydrogen or Na for sodium, for example. Subatomic elements. Neutrons, protons, electrons. Neutrons are no electrical charge found in the nucleus. Protons are positive charges found in nucleus. Electrons are negative charges found outside of the nucleus, moving in orbitals. Mass number is equal to sum of protons and neutrons. Electrons have about 0 mass. Atomic weight changes with gravity. So here's 2 models of helium. There's inside the nucleus, like proton, neutron, and outside the nucleus is an electron. Okay, and here's the little diagram at the bottom. Atomic number. All atoms of an element have the same number of protons. Also gives number of electrons if an atom is electrically neutral. Periodic table. Elements, chemical and physical characteristics recur in a predictable manner. Atoms are arranged in periods, rows, and groups, columns. And here's the periodic table. Isotopes. Atoms of the same element that differ in the number of neutrons. Isotopes have the same number of protons but a different number of neutrons, different mass numbers. Unstable and may decay. Emitting radiation. Radioactive isotope behavior is essentially the same as a stable isotope of the same element. Can be used as a tracer. PET scan. Can cause damage to cells leading to cancer. Or PET scan, I mean. Can cause damage to cells leading to cancer. Can be used to sterilize medical equipment. Arrangement of electrons in an atom. Arrangement of electrons in an atom. Electrons are constantly moving. Useful to construct models of atoms with energy levels or electron shells. Each shell contains a certain number of electrons. For atoms up through number 20, 2 electrons fill first shell. 8 electrons fill each additional shell. Octet rule for valence shell. Valence shell is the outermost shell. If an atom has more than 2 shells, the outer shell is most stable with 8 electrons. Atoms can give up, accept, or share electrons to have 8. Chemical properties of atoms are largely determined by the arrangement of their electrons. So here's a whole table. Love that. Okay, so types of chemical bonds. Molecule, which is a group of atoms bonded together. So we see O2, H2O, C6H12, O6, and N2. And then a compound is a molecule containing atoms of more than one element. So we have H2O and then CH12O6, which is glucose. Then we have two types of bonds. Ionic, attraction between opposite charges, and covalent, sharing electrons to complete our shell. Ionic bonding forms when two atoms are held together by the attraction between opposite charges. Sodium has 1 electron in a valence shell, usually gives up an electron. Chlorine has 7 electrons in valence shell, usually accepts an electron from another atom. Ions are charged atoms. Sodium, 11, has 1 more proton than electrons, now Na+. Chlorine, 17, has 1 more electron than protons, now chlorine minus. Ionic compounds, often called salts. Covalent bonding. 2 atoms share electrons. 2 hydrogen atoms can share electrons to fill their outer shell, or orbitals overlap. Structural formula uses straight lines, HH. So, creating H2. Molecular formula. One line indicates 1 pair of shared electrons. Okay? And then molecular formula simply shows number of atoms involved in H2. And that is the end of this video.